Hi guys, welcome back to my series on MPLS and DMVPN. Uh, the last time what we took a look at was how to connect up multiple sites to each other using MPLS VPN and then encrypting that traffic using DMVPN. By encrypting or setting up a DMVPN on the customer edge sites, it gives the customer the capability of hiding their internal networks from the service provider. Now, what I want to do in today's video is take it one step further and introduce the concept of a front door VRF and an internal VRF on the customer edge routers. What we have right now, let's analyze that and then we'll go ahead and take a look at uh, what we need to do over here is what we did the last time round. We set up a network which looks like this. We had the provider cloud over here, which was SP AS100. I had four sites, customer A Dubai, which was set up as a NHS next hop server, and my routing hub for DMVPN, which is still set up. We're going to take it off because I want to set up a different topology over here. We had three other sites. We had London, we had Los Angeles, and we had New Delhi connecting to each other. Let's analyze that network, and I'll show you what the difference is, what we're going to do over here. I'm going to connect up to my routers. This is my Dubai router, the headquarter router. If you take a look at the headquarter router over here, show IP route EIGRP. These are the routes that I've learned from my different customers. I have 10.6, 10.7, 10.8, 10.5 is my own site, 66, 77, 88. These are the different networks that we have at the other sites. That's London, London, New Delhi, and Los Angeles. I'm at the Dubai site, R5. So if you go to router 6, I'll see the other sites on there. Oops. Let's take a look. Show IP route, EIGRP, 568, 55, 77, 88. My objective over here is to provide an extra layer of isolation on the customer edge routers. What I want to do is this. I want to be able to not only isolate my networks from my service provider, but within my internal network, what I have is I have two separate departments that I want to connect up in two different tunnels to each other. They'll be independent of each other. So if a device that I have over here, let's say on the sales network, he should only be able to communicate to the sales people on the three other sites that we have. I don't want them to be able to see each other between marketing and sales. Right now, I do have that capability that they're in the same routing domain. They see each other. Let me show you that. For example, if I go to router 5 and I check my normal routing table, you will notice that on the routing table over here, I see both the 10.6 and the 10.66 networks. I don't want to do that. What I want to do is I want to segregate 10.66 and 10.6 into two different networks, 5 and 55 into two different ones, 8 and 88 into different ones, 77 and 7 into different ones. The first thing that I want you guys to understand is the concept of front door VRF and the internal, the IVRF. When I create a VRF, this by the way will be VRF Lite because I'm going to be doing it without MPLS. It's going to be inside my network. When I do that, I have a concept of VRF which is used for forwarding. What is exactly what I'm going to do on my tunnel interface that I create, this tunnel that I have, I'm going to have a tunnel over here which is tunnel 1 for the sales, and I'll have tunnel 2 logical interfaces running over the same physical link over here. I'm going to put VRF forwarding for this guy and that guy. That's just for the traffic that has to go through the tunnel interface towards the inside network. But you also need to understand that there is another aspect of the tunnel, that is the reachability aspect. That's where the front door VRF comes in. When R6 needs to communicate to 5 or 5 needs to communicate to 6 or 7 and 8 for the two different tunnels, its reachability is through the global routing table that I have over here. I have a single routing table that I'm going to use for both tunnels for reaching its destinations. That outside network or the outside routing table that I have is still global. I'm not using any type of VRF on my outside link. That's the link connecting my CE to my PE. If I did use a VRF on the outside interface for reachability, that would be my front door VRF. So in this particular lab, I am not going to be using the front door VRF. We're going to do that in the fourth video in this series, where we're going to use the VRF on the outside on the PECE link to connect up my different tunnels to each other. So that would generally be done if you have an isolation of two different service providers. I don't have that over here, so I'm not going to use a front door VRF. So the reachability of R5 to R6, R7, R8 in the tunnel, basically the NHRP reachability is not going to be done inside of VRF. So in that case, I'm not going to use any front door VRF. I'm still going to use an internal VRF to segregate my internal traffic over the two different tunnels. So my objective over here is to set up two tunnels, tunnel 1 and tunnel 2. One tunnel which will be used to connect the sales VRFs to each other. The second tunnel will be used to connect the marketing VRFs to each other. I'm going to use Dubai as the NHS for both, for sales as well as for mark. But before we do that, let's get rid of the config that we have right now under my tunnel, under my routers. So basically what my objective over here is get rid of the tunnel interfaces on R5, R6, R7, R8. Once that's done, the next thing that I'm going to do is right now I'm using for tunnel reachability, I have created a loopback which is advertised into my PEC routing protocol, which is based on 172.16.1.5 on R5, 172.16. These are loopbacks, loopback 10s. I'm using 6 over here. These are all loopback 10s. This is my tunnel source, tunnel destination for tunnel 1 right now. I'm going to use that for sales. And this is 7. And this is going to be for 8. I'm going to use that for tunnel 1, but I'm going to create a different loopback, loopback 11, that is going to be used as my tunnel source, tunnel destination. Let's create it as 55.66.77.88 for my second tunnel source and destination for the reachability of the tunnels. All right, so let's do that and advertise those links inside my PEC routing protocol for reachability. That's my objective right now. So the first step, get rid of your tunnel interfaces that I have between R5, R6, R7, R8. Create a new loopback that I'm going to use for the two tunnels as source and destination. I'm going to use 172.16.1.5, 6, 7, and 8 for tunnel 1, 55, 66, 77, and 88 for tunnel 2. So step number 1. Let's get rid of the older tunnel, tunnel 1. I'm going to get rid of that. No interface tunnel 1. Got rid of it. Now let's start with 5. I have loopback 10 that I'm using for my tunnel source, was using it for tunnel 1. I'm going to still keep it for tunnel 1. That's this network over here. I'm going to create a tunnel 11. All right, should pop up any minute. There you go. And let's check my routing, because I need to run it with my PEC routing protocol, which is 1234 as the AS number. Advertise 55 as well. Good. Let's go to 6. Same concept. In here I've done this, so I'm going to get rid of that and be more specific. 1.6 and 66. Good. 7. Bear with me, it hangs a little bit over here. Let's check if I'm getting the routes now. I'm getting 5, 6, 55, 56. 7 is myself, so I should also do this to check it. Should IP route include 172.16.1. 5, 6, 7, 8, 55, 66, 77. So the only one left is this guy. All right, come on. 1.88. Good. This is good. Five, 6, 7, 8, 55, 66, 77 is not popping up. So let's verify 77. What did I do over here? My address is okay. I think. Put it at 1, 2, 3. So now I should see 77 as well. So these 172 networks that I have are going to be my tunnel source, tunnel destination for the two tunnels. That's the reason I created it. So my next objective over here, we'll do it one step at a time, is to create a VRF for sales, bind it to the loopback 0 network, which is 10.550, and on the outside I'm going to create a tunnel that will allow me to connect the 10.5 network to the 10.6, to the 10.7 and the 10.8 network. So I'm going to have two VRFs on each of the routers on the inside. On the outside, the tunnel interface will be in the VRF for forwarding, but the actual NHRP resolution will not be done based on the based on a VRF on the on the outside. It's going to be done based on the global routing table. If I was doing the resolution of my NHRP by an interface that's in a VRF, that would be your front door VRF. Again, as I said, we're going to do that in the next section, not in this particular one. So with that in mind, let's go ahead and get started with Dubai router 5. I'm going to focus on sales first, get sales up and running, and then we'll do marketing over here. So on Dubai, I'm going to set up my VRF for sales. How do I do it? Let's go to 5, VRF definition, sales. I don't need to specify any route distinguisher or route target because I'm doing VRF Lite, but I need to enable the address family for this particular VRF for IPv4 because that's what I'm doing. If you remember, I have that 10.5 network over here and the 10.55. Loopback 0 is 10.5. That's the one that I'm going to put into sales. So I go on inside loopback 0. That's what I've done over here. Let it pop up. VRF forwarding, sales. It will blow off the IP, so I need to reset the IP. Done. Once this is done, I can now go ahead and create my tunnel interface. How do I create the tunnel interface? I'm going to do it in Notepad and then paste it. So on R5 Dubai for tunnel 1, interface, tunnel 1, IP address. We're going to use 1.5 as the IP address of the tunnel. Tunnel source, loopback 10. What is loopback 10? That is that 172.16.1.5 network, this guy over here. Okay. Remember I said 1.5, 6, 7, and 8 will be the tunnel source, tunnel destinations. So that's what I'm using, loopback 10 over here. Tunnel mode, GRE multipoint, IPNHRP network ID 1, IPNHRP map multicast dynamic. Alright, IPNHRP redirect because I'm going to be running DMVPN phase 3 just like I did the last time around. And what else do I need over here? No IP split horizon. I'm planning on running EIGRP 111, so that's what I'm going to do over here for this one. I'm not going to apply the crypto yet. We'll do that in the next phase. Let's get it up and running first. In terms of the routing, router EIGRP 111, address family, IPv4, VRF, sales, autonomous system. We'll use 111. Network 192.168.1.0, and to make it simple on myself, I'll say 10.0. Alright, let's get this up and running. This is my hub site. Copy it, go to router 5 and paste it. The only thing is, under the tunnel, I have to say IPNHRP map multicast was misspelled. Other than that, everything looked good. Okay, so let me just multicast. Everything else was fine. Now on are the spokes. I'm going to start with 6. Also uses loopback 10, multi-point, my NHRP, NHS 172.16.1.5. How do I reach it? actually sorry, 192.16.1.192 168.1.5 map to it. To get to it, I'm going to go through 172.16.1.5. I don't need that. Map multicast, again I'm going to put it to the hub. Shortcut over here, don't need the split horizon. This stuff looks good because it's the same. Oh, but before I do that, I'll copy this. I need to do the VRF creation and stuff. Copy it. We'll go over here and create the VRFs on 6 because it does require the VRFs to be done. VRF definition, sales, address family, IPv4, interface loopback 0, VRF forwarding, sales, blows the IP, sets that up. Now my inside interface is done. Multicast is still an issue. The other thing I forgot to do is I need to put the VRF forwarding on my other device as well. So let's do this real quick for both interfaces. Multicast I did fix over here, but I needed to start this with VRF forwarding, otherwise it would blow the IP. So what I'll do over here, tunnel 1, I'll just do this again. Copy. Go to router 5. That takes care of that. And then router 6, I'll do the same thing. That's my IVRF. Did I fix multicast? No. Now it's fixed. Copy. Go to 6. Blow the tunnel off, bring it back up, and my tunnel should come up, and my EIGRP should come up. So now if I take a look at show IP route VRF sales, I should see the 10.5 network. There you go. And once I'm done with one of the spokes, all I need to do is the same thing, just keep on changing the tunnel IP. The rest of that remains the same. Having said that, I still need to go to the spokes and create those VRFs. Come up. Come on. Apologize for this. I'm accessing the other PC. So that's why it just hangs sometimes. VRF definition, sales, address family, IPv4, interface loopback 0, VRF forwarding, sales, 10.7.7.7. Alright, now I can paste that tunnel network. And my tunnel should come up, and inside my VRF sales, I should see 10.5 and 10.6. Cool. Let's go to 8. Done. VRF forwarding, sales, IP address 10.8.8.8. Now I can go over here and change this to 8. The rest remains the same. It's the same config for both sides. all sides, all spokes are the same. Where's my, there you go. Tunnel up, EIGRP up. Cool. 5, 6, 7, 8. I have the ability to go there. If I do a trace to 10.6.6.6, source of loopback 0. Don't forget, you need to do it for that VRF now, because I'm also running a VRF on the customer side. The first one goes to 5, 6, does the NHRP redirect, and then goes directly to 6. Now I have a 6 connection. So my DMVPN phase 3 is working between R5, 6, 7, and 8 for VRF sales. Alright? Now that I've done that, I can also encrypt it. If you remember, on these same devices, I had set up my IPSec using transform setup ABC, which was called in an IPSec profile called III, which I haven't applied it to my interface. That's what I'm planning on doing now. So I can also encrypt the traffic, and it's going to be III for all of them. So all I need to do to encrypt this traffic, because my IPSec configuration was already done in the previous lab, all I need to do is tunnel protection, IPSec profile, call that profile that I had already created called III, and I'm going to apply it to all my tunnel interfaces on all my devices. So we'll start with 5, the hub. It's going to bring the neighbor relationships down because of EIGRP. One side getting encrypted, the other one not. I'm going to do the same thing over here. Neighbor down, put the profile to encrypt, and neighbor should come up. Brilliant. So if you take a look at show crypto IPSec SA, you should see my packets getting encrypted, decrypted. Okay. The other command that I want you guys to see is show crypto sessions detail. It will show you that although you have an internal VRF called sales, you see that over here. There's my mouse. It hides it. Just 1 second. Oh yeah, that's see that internal VRF is IVRF, because I'm not using any type of uh, VRF on the front door. That is the next hop routing protocol, NHRP reachability. That's why it says the front door VRF, I don't have none. That's the VRF. If I had a VRF on my interface that connects from PE to CE, I don't have a VRF on that. I have it on the tunnel. That's why the front door VRF is none. I'm just using the IVRF sales right now. Now, what I've done at this point is half the stuff. I basically, at this time, I've set up a tunnel. Which tunnel do I have right now? I have this tunnel 1, up and running, connected to the sales VRF, which allows 5, 6, 7, and 8 to talk to each other. I want to repeat the same thing for the other one, which is the mark VRF. And basically what I'm going to do is I'm going to use the same type of config that I have already in Notepad to set up a separate VRF called mark. I'm going to set up mark on the Dubai router, the London, the Los Angeles, and New Delhi routers. Once I set that up, I'm going to set it to the tunnel. I'm going to create a separate tunnel for it, tunnel 2, using a different address for the tunnel, as well as the tunnel source, tunnel destination. That's where I'm going to use that 172.16.1.55, 66, 77, and 88. That particular loopback, because it's providing the reachability, the NHRP reachability for the tunnel interface. needs to be advertised in the PEC routing protocol in the global table of the customer edge. All right, so let's do this over here. Let's try to do the stuff in Notepad so I can copy paste it. So let's start with the hub. The first thing that I'm going to do over here is VRF definition mark address family IPv4, go to loopback 1, VRF forwarding mark IP address for this guy was 10.55.55.55. Need to reinstate that. Now the tunnel. I don't have tunnel 2, so I don't need to worry about that. Tunnel 2, VRF is going to be mark. I'm going to use a different address for the tunnel. Source address loopback 11, that's the 172.16.1.55. Use a different network ID, and I'm going to use a different autonomous system for it, 2222. Change that over here. Change my VRF to mark and my autonomous system to 2222. So this should be the config that I need to do to set up the IVRF mark on router 5. Again, create the VRF, that's the definition, enable address family IPv4 in it, create the loopback and put it inside the mark VRF, reassign the IP address, go to the tunnel interface, put the tunnel interface into VRF marketing or mark, set a different address from the other tunnel, tunnel source, the 172.16.1.55, tunnel mode, network ID I kept it different, although I can keep it the same because there are two different VRFs, map multicast dynamic, NHRP redirect, no IP split horizon EIGRP, the normal stuff from that point on. Copy this and we'll paste it to router 5. Now the tunnel comes up, but I won't be able to do anything right now because in order to see it, I need the other spokes to come up. So for that, I'll go back over here and change my spokes the same way. This part over here and the spokes will be the same, so I'll copy it. Mark, this is good, this is good, this is going to be 66 because I'm doing it for router 6. Tunnel interface, I'm going to change it to 2. Forwarding to mark. The IP is 2.6. Loopback 11. This is 2. NHS is 2. This is going to be 55. That's the address that I'm using. Map multicast 55. Shortcut, this is good. 222. VRF is mark 222, and this network is 2. So again, create the VRF, put the loopback in it on the tunnel, put it into the marketing VRF 2.6. The loopback is 11, that's the 1.66 as a source. Destination will be 1.55 to do the mapping to the NHS. Also my multicast, NHRP shortcut for DMVPN phase 3. My EIGRP autonomous system is 222. So now that I've done that, copy this over here. I'll go to router 6 and paste it. Alright, anytime now. It hangs up if I don't keep on constantly typing on it. So once it does that, come back, it should be okay. 6, paste it. As soon as I do that, it should pop up. The neighbor relationship should also come up. If everything's fine. Something is wrong. Let's check. Can I ping it? First thing I want to do is I want to see if I can ping 1.66. That's good. That is reachable. So there's something wrong with EIGRP then. Oh yeah. See this? It should be address family. I should put the network as 2.0, not 1.0. Probably over here. Okay, I lost my mouse. There you go. This was on the hub site was set to 1. That's the reason that it all comped up. So I'll just change this to 2. Let's copy paste it. Alright, brilliant. So now my neighbor relationship is up. Show IP route VRF sales will have the 5, 6, 7, and 8. And if I go to marketing, I should have 55 and 66. Now that we know the config looks proper for the spoke, we'll just change this 77, change to 2.7. Everything else remains the same. That's the beauty of DMVPN. Once you set one device up, everything else should remain the same. Copy, except for the IP of the interface, which needed to change. Let's go to 7. That hanging again because I moved away. Paste it. Interface up, tunnel up. Again, show IP route VRF mark should have 55, 66, 77. And if I check sales, it should have 5, 6, 7, and 8. They're both isolated behind the CE routers. Now the last one is number 8. And the only thing that I really need to change over here is these two things. The rest can remain the same. Copy it. Go to 8. There you go. Show IP route VRF mark should see the 55, 66, 77. If I do a trace to, let's say, 66, source should be loopback, I believe, 11. Come on. I'll just use 88. Oh yeah, the problem over here is trace. I need to do VRF mark. There you go. So first through the hub, 5 and 6, and then it should go direct. That's DMVPN phase 3. Now the last thing I need to do over here is paste my profile to it. So we haven't done that yet. Copy it. It's wrong one. Let's start with the hub. Oh, I need to do it for tunnel 2. So tunnel 1 already had it. This is the last portion, and then we'll just check the IVRFs for marketing as well. This is done. This is done. This takes care of that. Expired because of the encryption on one side. Back up. Now if you go to any of these devices, show crypto session details or detail. So for 1.88, I have the front door VRF as none, IVRF as mark. Same thing for 66. Same thing for 77. That's tunnel 2. And you would have the same thing for tunnel 1 for IVRF of sales. Cool. So this is MPLS VPN with DMVPN using an IVRF where I've segregated the traffic between the two inside VRFs over two separate tunnel interfaces using a common PEC link. That's why I'm not using a front door VRF. If I was using a VRF on the outside as well to segregate the traffic on the PECE side where the NHRP is, that's where I would use the front door VRF concept. Alright, so stay tuned. I will also post up the FVRF video to show you how DMVPN will work with a front door VRF. Thanks for watching. You take care.